Alright, welcome to a rare early morning video. Even where I don't think I've ever had a early morning video, but concurrently this is also the early morning video. So we're gonna get working. Oops, it looks like I have the classic issue with Chrome where sometimes it doesn't boot up. So there's like a hung process that I can just Control-Delete and end task for, and then once I do that I can boot it up. Okay, it looks good to me. I thought about it a bit this morning about which device I want to take the test on. Do I want to take it on my work computer or my personal computer? I think a case can easily be made for either one, but the case for my work computer is that I get all my emails for my work computer. My employer can use this certification for vendor discounts, so in some ways it is a little bit related to my work. It's oh, and then yeah, that's the main argument for doing that, is that my account and how I registered is tied into my work email. And not only that, there's some additional good reasons. My work laptop is just a better laptop. My personal laptop I've had for going on many years now, and it's got some serious problems. The trackpad is completely broken where the buttons on it are. It doesn't charge up anymore, so if the cable comes out, it just instantly powers off. And the worst part of all, the cable doesn't the cable gradually always comes out, no matter what you do. So every hour or so you've got to push it back in because it very slowly works itself out somehow. So if I don't constantly make sure I'm pushing that back in every hour or so, my computer will just straight up crash. I'll give a little bit of a warning because it'll like show that it's out of power or whatever, but I often have had problems with that, and that's not gonna happen on my work computer. Okay, so last video we were watching a series by oh, I forget by, we'll look it up. I think it was like Packet Pushers or something. No, Decoding Packets. Perfect, amazing series. Thank you to the people at Decoding Packets. It's a companion to a blog. Let's see who it's run by. So it looks like the person who does this kind of prefers to be anonymous in some sense because they don't really have their information posted. Yeah, it looks like there's not much information about the people behind this site. But I mean, the information looks trustworthy. So far it's been, I think, pretty good, so I have kind of no reason to doubt the information here, especially when, as we've seen, the information on the Juniper site has been really kind of not adequate to learning this subject. So it looks like the older version of this site was Nets Craftsman, and there were multiple authors working for Nets Craftsman. So I'm guessing that the person behind this new site is probably one of these bloggers, or at least adjacent to one of these bloggers. So that's good. Looks like there's a well curated team of professionals behind the original site. So in my opinion, that gives this current site a lot of credibility. I wonder if they have. No, I don't see anything for service provider. Yeah, so here's the architect. So he's probably got a number of certifications. Yeah. So yeah, he's a CCIE. That's good enough for me. I know what that takes. I'm going for my JNCIE-SP, and just a single CCIE is very, very, very respectable. There are people with like 3 CCIEs and 2 JNCIEs, but there's a point where, you know, if all you do is study for tests and take tests, in my opinion, your kind of professional experience is held on a equal or even perhaps greater level sometimes to exams. So I got to look into. I mean, not that I can assume that the person I just looked at has more valid and has better professional experience than somebody with multiple CCIEs and stuff. Not that that's the logical conclusion to that, but basically all I'm saying is that it's judging the expertise of a person based solely on their certifications is a good strategy in my opinion, but it's not foolproof. Okay, so let's keep going on this video.
On rec 200.
So we actually got I had to pivot a bit because the host's routers turned out to be requiring Cisco's, and I just had virtual PC hosts that basically all they have are some T-shooting tools like ping and traceroute, and then they have the ability for a unicast IP. Well, you could probably put a multicast IP on there in the multicast range, but any multicasting protocols such as PIM, it seemed as though the virtual PC did not have. So they're going to have that here. Let's, first things first though, set up the IP addressing. Alright, yeah, so that looks good to me. Okay, so now let's follow along with the video where he's setting up PIM. So we're at the 3936 mark. He did that pretty recently, so let's go to 3900.
Interface that is of consequence, which would be the interface with this IP address. So I'll quickly say do show IP int brief, and that is gig 00.56. I'll go to that interface, and I'll say IP IGMP join group.
Okay, so he's using VLANs on there. I don't think we're going to need to do that. So let's just keep it simple, I'm going to GI00, and then it's going to be IP IGMP join group.
And we'll join that 239.1.1.1 group. On rec 200.
Oh no. Okay, so it looks like my flavor of iOS is a bit different than his. So let's see what we got. It looks like we do have the IPIGMP join command. Ah, okay, but in my flavor of OS, I don't need that extra group keyword. Perfect, so let's keep going.
Show IP ID brief.
Okay, so now let's do the verification steps. Okay, so we'll do a show IP mroute. Okay, I think this is from before. Ah, and we do have this table enabled now.
And I'll say IP IGMP join group, and we'll join that 239.1.1.1 group. On rec 200, we'll again say show.
Okay, so now he's setting up the second one. I don't even have hardware for that. Well, software, it's a VM, but you can call it hardware in this case. I don't have that set up yet, so let's do that first. First things first. Second things second. Okay. There we go. It's going to take a little bit of time to boot up. I think I might take a quick break. I'll be back. Alright, I'm back. So we've got this up. So I'm guessing the next thing will be, let's see here, show IP int B. Ah, so we don't have the IP address yet. Let's set that up. Okay, IP address. And let's take a look. 172.26.56.200/24. Oops. Okay, no shut. So we'll need another address on here. It's going to be the PIM address.
IP ID brief. And it's the same interface, so we'll go into that interface. Gate 0056, IP IGMP showing group, and this would be 239.2.2.2. So now we have joined two groups. These groups should be sending the IGMP membership reports up to the last hop router. So let's take a look on R5 and R6. So first on R5. Run show IGMP group. So looking at G00.56, that's the group we are interested in. And here is 239.1.1.1. And here is 239.2.2.2. So they have...
Okay, so obviously something went very wrong on mine. I don't have any of the output he has. Let's take a look at the configuration, see if I might be missing something. No, it looks good to me. We've got protocols PIM interface all. That I think is really all we're going to need. Let's see if we can ping those other addresses. Ah, so I can't ping .100, and of course I probably can't ping .200. Huh. Can I ping myself? Okay, I can ping myself. When you can't ping yourself, there's a huge problem, but okay, and it's going to be a directly connected router or route. Okay, but this is obviously a big problem. I can't ping through the hub. So I see the problem. I decided to do 172.16, and that makes sense because that's really common to configure. It's the private space. We're going to be using public space. Alright, so let's see if I made that same mistake on router 9. And in the meantime, we can go back. Hopefully those pings will start going through. Try it again. Nope, those pings still aren't going through. But let's see how router 9 looks. Okay, so router 9 looks a lot better. 172.26.56.200. It's just router 8 that seems to have the problem. Now I don't think I'm going to need VLAN tagging on here because, yeah, it should be fine. I don't think it's going to send a tag. Let's just get a better sense for what is happening on the wire. Okay, so let's see if those ICMPs show up. This is interesting. We don't have any, even though I've got it running. So it looks like, yeah, it looks like the ICMPs aren't even being sent because we're having problems with ARP here. Oh, and it looks like it is sending a VLAN tag, so that could be our problem right there. We don't have the VLAN set up on the Cisco's. Let's try that. But I thought you didn't need a VLAN. I'm confused. No, you need one. You need one. It's got to be a router on a stick configuration because the tag is actually being sent, so it's got to be received as well. Yeah, so I need this encapsulation dot 1Q56. That's because there's a header here with VLAN 56. So it's got a, if you're throwing a baseball, you need a baseball glove. To catch it. Okay, so we're going to be moving both of these down to the virtual interface. But it's as easy as simply doing that. Really nice and easy. going to need to do the same thing on rudder 9. Perfect. So now we've got those pings. Hopefully we have better luck with the show command. Yep, and now we've got ICMP traffic coming out. One thing I'm really... Oh, you know what? So I was expecting there to be ICMP requests, but no ICMP replies. But let's take a closer look at what actually happened. So I'm going to stop the capture, pull it up. So you can see we do have requests and replies now, of course, but let's see if there was ever a point where we were only sending requests and we were just receiving replies. Okay, so as far as I see now, we've always got a reply where we've got a request. So is there a point where we will only have requests but no replies? And the answer to that is no, and we can see that's because the ARP was unable to resolve. So we didn't even have the ability to send an ICMP request because we were not able to map the IP address to the MAC address of the remote host, so we had no destination to send the ARP. Sorry, to send the ICMP request. Now, yes. Now, for somebody who's learning this new, that might be confusing because what do you mean we have no destination? We have the IP address. Well, in a layer 2 segment where you're not routing, you don't use IP addresses to identify the end host. You use MAC addresses. So here we go. We got to use that ARP to get that MAC address, and then once we have that, we can fill in this field, because before we had these ARP messages, this field was, not empty, but it was filled in with a placeholder, which was the broadcast. And you can see every piece of traffic we have that is not a response to the ARP has either a multicast or a broadcast MAC address. So hopefully that makes sense. Let me know in the comments if it does not. Oh, it looks like we've got some loop replies that have specific MAC addresses in them, but these loop replies can't be used to hang on to this information. It looks like it just comes and goes with these replies. You got to use ARP to actually hold on to this information. So, yep. So ARP is asking for this information. Okay, and then and now we get it. So now our ICMP requests can have this filled out because it actually has that information now. Alright, so hopefully we'll have better luck with this command now, which is show IGMP group. Aha, so yep, now we've got the interface in there with the group that we assigned it to, and we can see it's coming from host 1. and it's dynamic. Oh, we've also got a second group coming from host 2, so everything looks great.
Been signaled by rec 100 and rec 200 respectively. There are no sources for them here listed, so that just means it was a star comma G join or any source multicast join. Also on R6.
Okay, so it was a star comma G join. Like that. So the source doesn't have to be specified.
For multicast, it only sends one, so we'll say repeat fine.
Okay, and it looks like I skipped ahead quite a bit by accident. I think I skipped ahead like a lot by accident. Like I think I was at like the 47 mark. I don't remember. Yeah, I think I was like way back here.
So that's for backwards compatibility with version 1. It's 239.111. It is a signaling here. Run show PIM join. And now we actually see static address 172.26.0.3. That command goes in. On R3 I'm going to say, on R5 let's also look at run show PIM join on either one of these routes. Also on R6, run show IGMP groups or group. And again on GE56, I have 239.111, 239.222. There is nothing else here. The extra groups you see on R5, I suggest that you watch the receiver signaling videos.
Okay, I'm confused here. Let's look at my notes and see where I started this at. Okay, so when I first sat down to this, I was at the 39-minute mark. So I'm probably on that right now.
On Rec 200, there is nothing here yet. And the main reason for that is that R6 and R5 are not able to convert these IGMP signaling into PIM signaling because they don't. There is going to be are no sources for them, and it's the same interface. So we'll go into that interface.
All right, this looks very familiar to me. Let's keep going on this. We'll do it from here, even if it's a little bit. Not all the way.
JNCIE-SP IP IGMP join group, and this would be 239.2.2.2. So now we have joined two groups. These groups should be sending the IGMP membership reports up to the laptop router. So let's take a look on R5 and R6. So first on R5, run show IGMP group. So looking at G00.56, that's the group we are interested in. And here is 239.111, and here is 239.222. So they have been signaled by Rec 100 and Rec 200. Respectively. There are no sources for them here listed, so that just means it was a star comma G join or any source multicast join. Also on R6, run show IGMP groups or group. And again on GE56, I have 239.111, 239.222. There is nothing else here. The extra groups you see on R5, I suggest that you watch the receiver signaling videos, IGMP version 2 and IGMP version 3 videos that we covered earlier. I think they are demos 1 or 2 or something like that. But they're already half covered in the lecture series if you want to know what is the significance of those groups. But right now we're just going to worry about these two groups. The next thing here is going to be to see if PIM is actually taking these IGMP signals and it is converting it into PIM signal. So, and we don't expect to see that yet, remember, because we really don't have an RB on either one of these routers. So we'll say run show PIM join. And there you see, there is nothing here yet. And the main reason for that is that R6 and R5 are not able to convert these IGMP signaling into PIM signaling because they don't have enough information yet. On R5, let's also look at run show PIM join. And there is nothing there. And I'm trying to see if there is any command that would actually show me this, but I don't really think there are any commands. So let's look at the extensive command. And there's nothing. So essentially, Judas is even refusing to give any PIM information out, not even the lack of the RB, because we don't have an RB here. Run show PIM RBs, and there are no RBs. So let's circle back to that scenario 1 and bring the rest of the routers up to speed with set protocols PIM RB static address. And what I'll do is I'll do the lazy way of doing this. I'll send that command to every single one of the routers, and then we'll just delete that command. We'll roll back the config on R3. So we'll say set protocols PIM RB static address 172.26.0.3. That command goes in. On R3, I'm going to say, and this command may not have taken at every one of the routers, so let's send it again. And now it's gone to all of the routers on R3. I'm just going to say roll back 0. So when I say show compare, there's no difference now, and I'll go ahead and commit this on all of the routers. So as a side.
Okay, I gotta be in config mode for that. Okay.
in effect, the Cisco routers also get those commands, but they cannot really understand those commands. So that's quite okay. Every other router, all of the Junos routers have this command now. And now let me say first, run show PIM RPs. So now there is an actual RP address, and it is for entire class D because I didn't do anything to make it more granular, so it was basically a blanket statement. But you do see that there are two groups now listed here. So those two groups should be the 239.111 and 239.222 groups. Let's go ahead and see. R6 is the DR, so we should see something signaling here. Run show PIM join. And now we actually see more information in the PIM joins. So let's go ahead and take a look at this information. So first let's take a look at run show PIM join. So make it a little bit more granular. I'll say run show PIM join 239.111. So just concentrating on that group. I'm going to say extensive. The problem with the non-extensive or the regular version of this command is it doesn't give you some of the important pieces of information. So number one, it doesn't give me the oil, and that's almost worthless if you're trying to troubleshoot. So if you need a quick idea of which groups are beat.
Okay, so it doesn't give you the oil, the origin. So let's take a look at the difference between these two, because I'm still not entirely comfortable with the concept of an oil. I mean, I literally learned it yesterday. So let's just see what is missing. So this address is missing. So maybe that's the oil.
Bean signal, that's a good command, but if you really need any sort of information for it, you need the extensive command. So let's go through the extensive one. So just concentrating on that group. I'm going to say extensive. The problem with the non-extensive or the regular version of this command is it doesn't give you some of the important pieces of information. So number one, it doesn't give me the oil, and that's almost worthless if you're trying to troubleshoot. So if you need a quick idea of which groups are bean signal, that's a good command, but if you really need any sort of information for it, you need the extensive command. So let's go through the extensive command. Here is the group, it's 239.111. It is a star comma G group. So that is a little bit more explicit on Junos. So it actually tells you it is a star comma G group here. So it's any source multicast. This is the RP for that group. So now there is an RP, which is 172.26.0.3. That happens to be the RP for that group. If and when we look at these star comma G joins that go up to the RP, we actually will see all of the flags in there. So usually you have the sparse flag. The sparse flag is there in every single one of the joins. So that's for backwards compatibility with version 1. Some people may say that this is the SPD flag, but that's not correct. SPD bit doesn't really exist in PIM joins at all. So the sparse flag is always there, but here is that RP flag. So this is essentially, because you're using the same join for S comma G and star comma G, the RPD flag, as we discussed in the lecture, essentially now designates the star comma G join to go towards the RP address, IP address of the RP as the root of the tree. So with the lack of the RPD flag, 172.26.0.3 would be considered as a source, and this would become an S comma G join. Now finally there is the wildcard flag, and that is to designate that this is a star comma G or any source multicast join. So both those flags, anytime you have the RPD flag, you will also have the wildcard flag, because you would not be sending an S comma G join up to an RP. At that point it's just a source like any other. So RPD flag, wildcard flag, Juno shows you explicitly that they're here. The next thing here is the IIF. So IIF is the RBF interface towards the RP's IP address, and in this case there is only one address, or there's only one interface for R6 to go out of, and that is this interface here. So 46.4, or the interface between R4 and R6, and that you can clearly see is the IIF here. The next entry here is the RPF neighbor. So they are designating it.
Okay, so clearly there's some sort of problem here. I think the problem is that I was meant to add this command to all the routers. Yeah, I guess, well, let's just try adding it to the upstream router and see if that makes it look more like what he's got, because he's got this .4 here. So let's just add it to .4 and see if our command output looks a little bit better. Oh, so nope, it looks like it's the same. We've got no next hop, so I'm not sure what the difference is between what I've got and what he's got. I think the difference is that I don't have an IGP set up yet, and he's probably got one. That's why he has a next hop address. So I'm tempted to go and do that, but I don't know if that's necessary or not. I can't imagine why it wouldn't be. You definitely need a IGP if you want to learn all of the other routes. So you know what, let's just kind of take the risk, if you will, or take the, it's not going to be so much of a risk, but let's take the liberty to assume what's going to be configured on here, just using my own knowledge, which hopefully at this point is pretty sound, because if it's not, I'm going to fail that test. So yeah, let's do that. So we're going to do set protocols, OSPF interface all, area 0, interface all. Okay. Okay, so we're good to go. Next step, we're going to be rerunning that command that was shown in the video. Hopefully we get better results now. Oh, so we still don't have a next hop, even though we've got OSPF routes. Oh, it looks like we actually don't have OSPF routes. That's weird. Why don't we have any OSPF routes? That's the weirdest thing I've ever seen. The hell? Okay, we've got them here. Oh, okay. It just took a while to fill in. Okay, now we've got an upstream neighbor, all that sort of good stuff. So we're good to keep going.
It as the upstream neighbor, but it's really just the RPF next hop towards the RP's ID, which is 172.26.0.3. Next is the state that this group is in. So the upstream state says join to RP. That means a start on a G join was sent up to the RP. That's all that means. Uptime, how long have you been signaling it for? And downstream neighbors, this is simply your. So that's the outgoing interface list. And in our outgoing interface list, there is only, it is a last hop router, so instead of saying 0000, R6 is explicitly putting its own address in there. And once again, the flags here are the same flags that you see up here. The timeout is infinity because right now it's being signaled by IGMP, and it's going to look at that IGMP signaling to pull the join back if needed. But that is how you would read this particular piece of information. So that is the start on a G join. Now this start on a G join should also be there for R4, for the second group, which would be 239.222. And you'll see pretty much similar information because they have the same group, they have the same RP for the entire class, they have the same upstream neighbor, etc., etc. Now this join, also not fine. So let's quickly take a look at the non-designated router. So let's say run show pim join extensive. And on first glance, it looks like that the signaling is taking place. But let's only look at the group that we are interested in, which is 111. At first glance, it may seem that there is signaling happening even on the non-RP router,
But those are just placeholders in case it has to become a designated router. But the actual upstream state is not. So there is no signaling taking place. If the signaling was to take place, this is just the data block that would be used for that signal, if need be. So if R6 goes away and R5 has to become the DR for the segment, then this is the information that will be used for this particular group. But right now, the state is not. So this becomes critical, because otherwise, if you don't look at this, and again, this is not something that's available in the short version of the program, and it can cause a little bit of confusion. So if I take this extensive away, it literally looks like I'm signaling this group as of right now, but really R5 is not signaling that group. So the next thing to see is where this join should go out to. So we are in this segment right now. So starting out from R6, the signaling should go to the upstream neighbor of R4. So this should be that star comma G join. It should have the SVT flags on it, and R4 should now create that star comma G state. So let's go on ahead with R4 and see if R4 has that state on here. Run show pim join 239.111, and let's go with extensive. So all of the information is here, the group's here, the source is here, the RP is the same, the three flags that we expect to see are here. The upstream interface, so this is the IIF, and this should be the interface towards R3, and as you can see, 34, so this is the interface connecting R3 to R4. The upstream neighbor is R3, 34.3. The upstream state is joined to RP, so that's good. And the oil has the R6 interface in here, so that means the signaling here looks pretty good. And once the signaling is complete here, R4 should further signal up to R3. So let's go ahead and see this. So that star comma G is now going to go up to R3. And once it goes up to R3, R3 should also create that state. So this R3 that's slightly off the picture should create that state. Let's go on ahead to R3. Run show pin join 239.111 and extensive. Before I do this, think about what the IIF here should be. So taking a look back at the topology again. There's the topology. Let's expand it just a little bit so we have R3 in place. Once we have R3 in place, what should be the IIF for this star comma G group? So the signaling is here, it's star comma G. What should be the IIF be? So remember, this is a rendezvous point tree. That means R3 should be at the root of that tree. And if it is at the root of that tree, there should be no IIF. It's essentially originating these packets for all intents and purposes. What it's going to do is it's going to relay the packets from the S comma G tree, but we really shouldn't expect to see any semblance of an IIF here. So let's go ahead and complete this map. And as you can see, the upstream.
Okay, so for R3, I was on R2. God damn it. What's wrong with me? I'm super hungry right now. I need to... yeah, I'm gonna need to take a break soon, but... I mean, the good news is I went to bed super early, so it's not like I didn't sleep well or anything like that. And that's good news because I've got a lot of time this morning. But let's keep going. I don't think I'll need to take a break quite yet, and hopefully I can. You see, there's only a few minutes left because I'm watching it on double speed, so hopefully I can finish this video before I need a break.
Stream interface where the IIF here is local, the upstream neighbor is local. Now for those coming from the Cisco world, it says explicitly here that this is local. So in the Cisco world, you would expect to see something like null interface here, so no interface, but something like 0, 0, 0, 0. So all IP. Now the upstream state is that, so the upstream state for the rest of the routers will send a join to the RP, but the upstream state here is I am the local RP, so no further upstream state. The oil is consistent, so the oil is going out to R4. That really means that the star comma G tree has been successfully signaled. So right now in our network, there is a star comma G tree. And that star comma G tree goes from R6 over to R4, and R4 over to R3. So all of those routers have a star comma G state, and R3 sits at the root of that tree. Let's take a look now at the structure of these messages, so the actual packet capture of them. So we will say, let's say PIM type 3, I believe, would be the join prune message. So the join prune message should be coming from R6, which is right here. 46.6 is the actual R6 exit interface, so that information is consistent there. The internet protocol part of it, so that is exactly what we expect to see. We expect to see a DDL of 1. So some of the important pieces of information here. The source is 46.6. The destination is the well-known PIM multicast address. The protocol is PIM. The time to live is 1. So all of those things we have already discussed before, but now we can actually see them explicitly. Next is the actual PIM header. It's version 2. It's join prune, so that's no surprise there because we filtered on that. Filtered on type 3, which happens to be the join prune type. And finally, the PIM options that would actually have the star comma G join in there. So in this case, the PIM options, the very first thing is going to be the RBF neighbor. So what R6 thinks to be is RBF neighbor. And before I mark this, let me open this up fully. So 111 is the only one we're looking at, but let's expand both of these. Okay, so that's all of the information in here. Now, the RBF neighbor, if you remember from the lectures, it is explicitly stated in the packet because on a multi-access interface where this 239 or 234.0013 may be received by multiple routers, you want to know which router did you intend the message to. So 46.4 is that router, so only 46.4 should process this message. Next thing is how many groups are you signaling? So you're aggregating some groups in here. Now remember, we have two groups. We have 239.111 and 239.222. So both of those groups are being signaled. What is the hold time for those groups? So how often should you get a refresh at minimum before you dissolve the state for these groups? So once again, it bears repeating. PIM is a soft state protocol. That means there is no acknowledgement for any of the joins. So that means you have to constantly refresh that and keep it in soft state. Hold time just determines how minimal, at minimum rate, how often do these groups need to be refreshed upstream. So R6, which is producing this message, it should at least generate this message once every 210 seconds, at least. It generates it much more often than that, but that's the bare minimum. If the upstream router doesn't hear this message for up to 210 seconds, it is going to expunge the state and your multicast tree is going to break down. Now the two groups, so those two groups are down here. This is the first group, and that is the second group, so group 1 and group 2. Group 1 happens to be the 239.111 group, so we expected to see that. Now the number of joins here just means, because remember, it is a join prune message. So at any one point you may be joining some sources and you may be pruning some sources. So this field here just says how many sources, what is the number of sources you're joining, what is the number of sources you're pruning yourself from. So right now there is a join to only one source, and this here now, if you realize, is the RP side. So even though it looks like an S-G join, it is really an RPD join, and the major reason for that is first the IP address is RP's IP address. The second thing is it has that R flag, so it is a rendezvous point tree join or an RPT join, and the final thing is this wildcard flag. So wildcard flag, that stands for the star comma G flag. So this should make it pretty clear how the same message can be used for star comma G as well as S comma G joins. And that brings us to the end of scenario number 1. So now we have a complete tree. We just don't have any sources, which we will be introducing later. This brings us to scenario 3, the next scenario. So let's take a look at what that is. Sources present with no receivers. So a source is multicasting on the topology on a certain group, but there are no interested receivers on that group. Let's go ahead and take a look at how we may do that in R topology. So in R topology, these are the only routers that are going to be involved. R1, R2 is going to be a transit router, but you'll see in a second why it won't be involved in the PIM processing at all. And R3, which is the RP. So what simply happens here is that the source starts sending a multicast stream. So let's decide what this multicast stream is going to be. Using our same convention, why not go with 333? So nobody has joined 333 yet, and this is 239.333. So the source sends it there. R1, which is the FHR, should now create an S, G state for it. Now this S, G state may not show up exactly as an in-route state, but it really is S, G information. So it's better to call it a state, but it's really not a state. It's just information about an active source. As long as you have those pieces present somewhere in your data structure, that's quite all right. Cisco routers store it in the in-route table. Junos will see you'll have to do a little bit more fetching to find sources that are present but there are no receivers. Because it's a corner case type thing, right? So it's more for the use of the selection. More often you are going to have receivers if a source is sending interesting traffic. So R1 should then create that PIN register message. It should be a unicast message, and it should be headed to the RP. The RP should then update its own state with S, G, and it should send a register stop on account of there are no receivers right now present in the topology. Also, that PIN register message is a tunnel message. So in here, you should also see the multicast packet. So we want to ascertain all of those things. So number one, that register messages are indeed unicast, and then that they also help tunnel the multicast packets inside them. So let's go ahead and into our topology to see what is going to happen here. So here's R1, and just to make sure R1 has the proper ID of an RP, let's say show R1 show PIN RPs. So it has.
Yep. So it looks like I've been sharing the wrong screen here. I've never seen that happen before. Oh, you know what? It's not detecting the second screen is what's going on. That's interesting. I've never seen that happen before. Oh shoot! I might need to just straight up. Oh no. Yeah, I think the only way to get it to detect the other screen, unfortunately, is to stop the video. I mean, I've only got like 5 minutes left. I apologize to my viewers, but I'm gonna have to do this. Kind of a dick move. This is really meant to just help me stay motivated studying, so I'm gonna just continue with this awful video. I apologize if anyone finds these useful and is just kind of unable to get any more use out of this video due to my technical difficulties. But I urge you, if you're watching me right now and you want to learn multicast, please go to Decoding Packets and watch that instead. I mean, if you just get some sort of like ASMR thing out of this, then hopefully this enhances your experience.
That's a good idea of the RP right now, and if I say extensive, I can see that there is no other information here. We know that the configuration was put in statically, so no dynamic dissemination protocol were being used, and which group ranges are covered. So run show PIM RP.
Show PIM RPS extensive. Oops, so it looks like we've got a problem here on R1. Let's check the routing table. Yep, looks good to me. So what the heck is the problem? Oh, I don't have the RP configured on here. I think that's the problem. Yep. Yeah, so it does need to be configured everywhere. Arrgh. Sorry, I'm really hungry. I should go eat something. Okay, so hopefully this works and I don't need the RP on routers 2, 3, and 7. Right now I've only got it on routers 4, 5, and 6. I might have it on router 3. I don't know. Okay, so now I've got the RP because it's configured. Oops, so we don't have a interface yet though. Interface none. We do have some group ranges. Let's just enable it on all of them. I'm pretty sure he said that it needed to be on all of them. Okay, and it looks like the only ones that were missing was from R1 and R2. Might be missing from this one as well. Yep, it's missing from here as well. Okay. Let's see if we get better results now. Ah, we still don't have a interface. Yeah, we still don't have an interface. I'm not sure what that's all about. But let's just keep going.
RPs. Yeah, I don't see anything else here, but that's mostly because there is nothing else to see here. Next thing, let's go to our source. And the source is going to just send, say, 5 packets, so let's send 5.
Oh, I see. Okay, so now we've got a source as well. So this is going to be a Cisco. I hate to do this because of how much of a pain it is to set up new BMXs, but it's even more of a pain to try to dance around the example and get off track and make mistakes. So let's just keep with what he's got to keep our lives easier. Then we're going to go ahead and open up the console on this, and we'll be with him once this comes back up. Kind of tempted to let me pause it quick. I'll be back in just a bit, and the router will be back up. All right, we're back. We're gonna have some more simple work to do. Let's rename this to source so that it matches the Dropbox drawing. Oh, the Dropbox drawing doesn't have host names, but we'll make our tab match the tab he's got by naming this to source. Perfect. And these tabs don't exactly match, but it's unfortunately we can't change the name. It's not that big of a deal to just have it be named differently. Okay, so we'll need to encapsulate this interface, otherwise we won't be able to receive that VLAN tag. Okay, so we've got a few more commands left. The command specifically for PIM. And I believe it's just one command. It might be two. Let's take a look. Okay, so we're gonna need a IGMP command, I believe. Yep, this IGMP join command we're gonna need. We're also gonna need a PIM command, I thought. Well, I don't see it, so I think we only need that IGMP join command.
ice packets out to that multicast group. So we'll say ping 239.3.3.3, and we'll
Okay, so I can't ping that because I'm not part of that IGMP group yet. Let's add this to that group. Before I do that, let's ping the other side. I just want to make sure that's not the problem. Okay, so there's the problem right there. I don't have the interface set up properly. Oops, so it looks like I pinged .16. Understandable mistake. .16 is the private space, what I'm used to configuring most. But even without making that mistake, we've got a problem there. So let's go and do a show IP-int brief. Okay, so everything looks right. 172.26.10. So why can't I ping? Let's do a show IP ARP. Just because, yeah, of course there's not going to be anything there. Okay, well this is a conundrum. Okay, so we've got no route to host. We should have a directly connected route. So that doesn't make any sense. Oh, I did a 216. That makes sense. That's why there was no route to host. So we got a route to host now. We've got a directly connected route. But unfortunately we're not able to ping. So here's our problem. The interface is administratively down. Perfect. So this ping should start going through shortly. Huh. Okay, even with the interface administratively up, we still got problems. Now I think the problem could be with the native VLAN. Let's set the native VLAN to something other than 1. I forget how to do this though. So the command is not native. Maybe it's trunk group? No, that's not gonna be it. Tarp? What is tarp? So it wouldn't be under Ethernet either. Yeah, I really don't see what it's going to be under. Oh, you know what? It's going to be under the interface. I remember now. So interface GI 00. It's going to be, actually it's going to be under .1 encapsulation .1Q 99 native. So we're going to have .99 be the native instead of .1. That way we'll be able to actually receive the tags on .1. I think that's going to make a difference. Nope, that's not going to make a difference. Okay, okay, well, now I'm confused. Now I'm really confused. I'm really confused right now. So I can't even ARP. Why am I so confused? Okay, so the ARP isn't coming back. And these have, yep, these have VLAN tags on them. I think it's because it's on VLAN 1. There's, like, Cisco, you're not supposed to use VLAN 1. But, I mean, it should be fine on a router. On a switch is where you really have problems. Oh, you know what? I'm missing just the regular encapsulation command. I thought I had that. I'm not sure why it disappeared. But I wouldn't be surprised if it was just me. That's what those extra show commands are for. In the sports world, from what I understand, there's a concept called the hockey pass, and that shows up in basketball. Basically, what the concept behind that is if you have a wide open shot or a wide open like, you know, I don't know what it's called, but a swing at the goal with your hockey stick. There's kind of a concept where you know, the defense is going to see you doing that wide open. Everyone's going to be closing in out on you, you know, prepared for you to do that because you're wide open and everyone's watching you. So kind of a better move than just shooting it, you know, under all this pressure and with people prepared for you to shoot it, is to pass it one extra time So when it's shot, the defense wasn't expecting it to be shot from where it is shot. And that's the way I understand that. I'm definitely not a sports guy. But yeah, that analogy, now that I really define it, kind of breaks down in this context. But basically all I'm saying is doing the extra command in this context is important. But I'm realizing now perhaps not for the same reason as it's important in sports. But it is a good kind of way to remember to not just sit and think and to actually get in and do extra commands that that you wouldn't think would be important to do. They actually can have a lot of value, even though you wouldn't expect them to. Okay, so we've still got a lot of problems here. Oh, so it looks like when I did that, it wiped out the IP address, but we can just add it back on. Okay, so I think the configuration at least looks good now. We've got a native, so it's set up to be the native now, so I don't think that's going to work. Yeah, it can't be the native, and it's the native by default, so we've got to set it to something else. So Cisco set different native VLAN. I thought it was like a global command. I wish I knew what command I was thinking of. I wish I could just see the command that I was thinking of, even if it's not the command on if it's not a valid command on my router. I know it's a valid command on some Cisco routers. But the problem, I believe, is that this is the native VLAN. I can always just make it easy on myself and switch to a new let's do a no, and then let's do a yeah. Yeah, so it looks like I can only set one as a native. So VLAN 1. Yeah, okay, so I think the command I'm thinking of is a command on a switch, Cisco switch. So since this is a Cisco router, it's not going to have that command. I'm curious what he did though. Perhaps he does have Cisco switches here is why it's different.
Let's say it would be 5. By default, for multicast, it only sends 1, so let's say it would be 5. So here we go. There's 5 packet.
Yeah, so I think the reason it works for him is he's got Cisco switches. Let's take some liberty here, and we're gonna switch the VLAN being used from 1 to 10. I believe 10 is not in use on the network. We can check that though. Let's do a show route 172.16.10.0. Okay, so yep, 10 is not on the network. We can see other addresses such as 34. Oops. Okay, now I'm a little bit confused. Oh, I did 16. I did 16 instead of 26. That's going to trip me up every time. I'm so used to doing 16 since it's the private space. Yep. So now I've got what I'm expecting. We can see that dot 10 is completely clear. So let's go with dot 10. Okay, so now we need to configure the other side, taking some liberty with the lab configurations, but I think it makes sense to do so. It looks like he's using a Cisco switch, where I am using a Cisco router. Oh, so we already have we still have the physical interface. We just deleted the logical units. We won't need to re-add that VLAN tagging to the physical interface or the description because we still have those. We'll just need to add a new VLAN ID for this new logical interface, and then re-add the same IP. I might want to change the address to, no, let's just keep the same address because then it'll more seamlessly fit in with what he has. If we use a different VLAN, it won't be all that different than what he's doing. The real difference will be changing the IP. Okay, so I think I should be good to go. Let's see if my pings now go through. I did forget to do the join command that we've got on the host Cisco devices, so I'll add that before I do anything else. Oh, and even before I do that, I'm getting a little bit ahead of myself. Let's do let's make sure that we're good to go. Okay, so yeah, that's the problem. Since it was a native VLAN, it wasn't able to accept traffic with a .1Q header. Yeah. Okay, so next step will be the IGMP join command. Cool. Oh, so we don't have anything, just like he doesn't have anything.
It's going out at multicast address as we speak. So on R1, if I say run show bin join, I do see that group. So I do see that group, and let's say extensive here. So on R1, I'm actually seeing information about that particular group that is active in my topology. Now I might be mistaking my earlier assertion with the RP, so I think the RP may not show this information, but fortunately you don't have to remember that extra tidbit for the FHR because it's pretty clear. The FHR has this information right here. So what is the group? 239.333. There is an explicit source for this group, so it's not a star comma G, because now you know the explicit source, it's 1.10, that's the address for my source. It is a sparse, so like I said, a sparse flag is there on every single one of these, every single one of the PIM packets. That's for version 1 compatibility with version 2. This other flag here, this SPT, or it's also called the SPT bit, and this is also the RFC. This is really not a flag that is used in any of the messages. This flag on the state itself means that simply that you received some packets, some actual multicast packets were received on the state, they were processed on the state. So if you receive actual packets down that S-G tree, then you can go ahead and set up this SPT flag. That's all that it means. But this is not a flag that you would actually see in the messages because it simply doesn't exist. Now the upstream neighbor should identify the IIF, and surely this is where our source is connected. It's connected on G0001. So that's the IIF. The upstream neighbor. Now this may be a little bit confusing because it says type, right? That just simply means that you're not receiving the packet from a PIM neighbor, you're actually receiving it directly from a source. So that's what that means here. You're receiving it from a source that is connected on one of your local subnets. Upstream state is a local source, so that again goes towards telling you that this is an FHR. It's directly connected to a source at layer 2. People are trying out how soon should you have to again receive another multicast packet from that source, and how long have you been up for. So all of that information, again, no extra command to learn here. Show bin join. Extensive is the same command, so that is a good thing. Now notice the lack of that W flag. The W flag is not needed because this is not a wildcard join. The RPD flag is not needed because this is not a rendezvous point join. This is just a simple exclamation, so it doesn't get any more simple than this. Now, let's go ahead to R3 and try to find the same information here. So first let me make sure if R1 still has that information. It's not been timed out. Nope, it's not been timed out. We still have some time. On R3.
Okay, let's try to open them all up again. So I can more easily skip between the two like he's doing. Oops, so they weren't all able to do that easily. Nope, denied. Okay, we'll just open them all manually. It doesn't take a lot of time. Okay, so next step. Yeah, okay, so we're good to go. We've got what he's got up there. So we'll switch over to R3. We'll do the same command he's got. Show PIM join 239.1.1.1 extensive. Yep, looks good to me. We've got more than just the interface he's got listed there, but I think we're good enough to follow along.
We will say run show PIM join 239.333 extensive. And this is where the problem is. I don't really see anything on R3, but from all that we've talked about, R3 should have received a register message. So this is where you have to be a little bit more creative to see that register state. So it's really just a register state. So Junos is right, there is no S-G tree yet, but how do you find that register state? So that command would be show PIM RPs extensive. Show RP, the show ID PIM RPs extensive. That would actually show you all of the register states that are on this RP. So remember that command for troubleshooting purposes, it's a little bit different than the run-of-the-mill command, which is usually show ID PIM join. But in this case, it happens to be show PIM RPs extensive command. That would show you this. So this is the group, and this is the source. Who is the first hop router? So which router is sending you that register message? So in this case, it looks like the default on Junos is to use a loop back address to send a register message. This is a little bit different than the other implementation that was using the exit interface. Now the good thing is, even the other implementation, there is a knob that you can turn to make this information consistent. But it looks like Junos is picking that LO0 interface and using that as the source address of this register message. The RP, well, I hope that is the RP because this is just that local, we're on local RP. And the state is that we've received a PIM register message. So I wish the state here said something like in register stop or something like that, but no, it just simply states that you've received a register message. And that's it. So now you have an S-G state on the FHR and on the RP. But what about this middle hop?
Okay, so we've got a little bit of a problem here. It looks like they've got an interface PPD. I don't know what that is. We've got interface none, so we're not populating this register state for RP. Looks like nothing shows up at all. It's just completely blank between group ranges and address family. So I think we'll need to resolve that interface issue. I'm not sure how we're going to do that. Now it looks like there is no, okay, there is a loopback on here, so now, is it because the local address on these routers is incorrect? Okay, so I think it could be that I just went with a static address that matched everything. I don't think that's correct. I think the static address has to match the loopback and it has to be unique across all routers. But let me make it perfectly clear that I have no clue if that's true or not. But I think it's worth a shot. It's worth the extra pain of configuring it. And we can always roll it back pretty easily. So let's just try that. Okay, this one's already good, this one is not. Oh man, oh yeah, didn't I say I wanted to take a break like a half an hour ago? I think I might have. So burnout is a thing, but hopefully I'm planning to completely burn myself out on November 19th, a day after the exam. That is my plan. I should, at that point, feel like I'm going to literally collapse on the 19th, not on the 18th. On the 18th, I should feel really good. Yeah, I completely missed configuring the loopback on here. So, of course, I believe I'm gonna have problems. Alright, the good news is we've only got, oh, okay, I'm missing router 5, so we do have one more to go. Oh, and it looks like I accidentally thought that this was router 5. It's actually router 6, so let's fix it. Okay, but I did get the loopback address correct on router 5, so I've got an easier correction to make. I don't need to correct the loopback as well, just the PIM-RP static address. Alright, so hopefully things look a little bit better for me now on router 3. So unfortunately they look the same. I'm not able to get an interface. We do have protocols PIM configured with all the fixings, but we still got issues. But let's just keep going, and hopefully it'll become clear as we go on what the issues are.
Up router. So what about R2? Let's go ahead and see if there is anything at all on R2. So run show PIM join, nothing. Run show PIM RP is extensive, and there's nothing. And that actually makes sense, because if this was a unicast message, then R2 really did not have any need to process that message at all. So it's a unicast message. It literally just funnels its way through R2. R2 just routes that packet over to R3 without ever checking the contents of it. So it's doing that hardware.
Okay, so the unicast package didn't make its way over to R3 for some reason. So let's verify the configuration on the Cisco. I might have forgotten the IGMP command on it. Oh no, it looks like I have it. Yep, so I've got the IGMP command. Now, I wonder, do I need a route on here? Is that what's going on? Let me try that actually, because otherwise I can't get bi-directional communication. Huh. I'm really confused again. I don't understand why. You know what? Let's try that, because I think that could be the problem. Yeah, because we don't. Well, let's keep going.
It switches it like any other pack. So it's not interested in the contents of it. So that means R2 is not really part of this SOMG state, but it actually makes sense. So as of this point, there's really no need to send traffic on that tree, or when an R3 just need to be aware of that tree. So you have an SOMG state here. You also have that SOMG state here. But on the middle hop router, there is nothing here. And you expect to see nothing here. So that basically jives with what we learned. Let's quickly take a look at that register message in our packet capture. So I'm going to say pin type is 1 for register, or pin.type is 2 for the register style.
Okay, so hopefully it's making its way down here. Oops, and I might need to take a quick break again. I said I was going to take one like an hour ago, and I never took one. This video is now going on an hour and a half, so I definitely need a break. So hopefully I can somehow find a will or a way to take one. So we still got problems here. Let's check the Wireshark capture that he's got. So pim.type equals 1, or pim.type equals 2. Oh, so we've got a problem here. Oh, I've only got one equal sign, I think. Here we go. I'm not sure what was going on, but whatever was going on is good to go now. Okay, and we don't have anything, unfortunately. Let's take a look at this link. PIM.type equals 1 or PIM.type equals 2. Okay, I think it's just freaking out on me because because I didn't have a space.
So here we go, there's the register message. Now I might be capturing this message again on multiple VLANs because I'm literally taking the entire topology and dumping it into my back capture, but this is the same message. I'm just capturing it on 2 different VLANs, is all that's happening. So here's the contents of that message. This is the register message that was sent by R1 to R2. Now the source and the destination, if you look at the summary up top here, they may be confusing. But bear with me for a moment, Wireshark is just trying to be overgenerous, and as it usually does, it's trying to help you a little bit. So it looks like this register message is a multicast. So if you look at this, this is literally the S-G state that is shown here. But really, it's actually the tunneled packet whose information Wireshark is trying to show you. So to prove that, let's look at the actual IP header. So this is the actual IP header. And then this actual IP header, number 1, is a unicast header. So the destination address here.
So I'm kind of having trouble just letting this go. I don't know why things are bad. Okay, let's just keep going.
Here is unicast, and this is that RP's IP. So that is exactly what I said would happen here. The source is the FHR's loopback. So Junos is keeping things a little bit more consistent. This is the loopback address of the actual FHR. So as you can see, this information up here can be a little bit misleading, but all Wireshark is doing is that it is giving you the information about the tunnel packet. So let's go ahead and see the PIM header here. Let me wipe this off. And let's expand everything so we can talk about this. So here's the PIM header. Let me expand this just a little bit more. That's a lot of information. So, okay, so here's protocol independent multicast. And that part should be easy to see. So protocol independent multicast, version 2, we are familiar with that. The type of the register message is 1, we are familiar with that. The flags here are important. So border no, that means this is actually an FHR. You're not doing any proxy registration of any kind. You actually received, the sender of this message, of this register message, actually received the packet from a directly connected neighbor. This is also not one of those dummy keep alive register messages. So it is a full-blown register message. And if it is a full-blown register message, then the next part here should be the actual multicast packet. So the next part should be the actual tunnel multicast packet, which if you look at it, source, destination. That was the source, so that was RS, and that was RG. So even right now you can see that this is that actual packet that has been tunneled inside the register message. So once again, here's the source in detail, here's the destination in detail, the time to live, the protocol is ICMP, so all of those things were set by the initial source. The initial source, when it sent the message, that's what it sent. And what PIM did was literally take that message and encapsulate it with a register header. And finally, you have the actual ICMP. It's an echo request, and all of the good stuff about ICMP would be in here. So let me wipe this off so we can see the rest of this, which there shouldn't be too much. There's the data. So it's some made-up data, ABCD, that is being sent. And let's compare it to the actual ICMP message that was sent. Let me see if I can catch that message. And there we go. So that was the actual message. This, up top here, the very first one, is the actual echo request that was sent by the original source, by command.pim. So if you look at this, this is the Internet Protocol's header for this actually is a multicast header, so it's 239.333. And the rest of the information, the time to live, 255. In our case, the time to live was 254, and that makes sense because the FHR incremented the TTL before encapsulating it in the register message. So the original packet had a TTL of 255. In the register message, the TTL was 254, so in the tunnel packet. So FHR R1 actually processed that packet before putting it into the register message. The rest of the things here, the identifier, the LEMBE, which basically identify the sequence numbers in which ICMP packets these are, 22 and 5632, 22 and 5632. So everything is kosher here. So now you can see that the actual ICMP packet is being tunneled inside the register packet. Before we come to the end of this scenario, here's the response from R3 back to R1. This is a register stop response, which basically just means that stop sending me, put yourself in timeout. If you have more packets sent, don't bother sending those yet. I have no need for them. I made sure that I've created an S-G safe for you at the RP. But for now, just go ahead and put yourself in whatever is our pre-agreed timeout. This is once again a unicast message sent from the RP to the FHR. But but there is no tunneling here. So in this case, you really don't need to tunnel any packets. All you say is this is a register stop message, and this is a register stop message for this S, G. That's all it's saying. So for this S, G. So in this, that actually is a little bit confusing because I believe usually what I would expect to see here is the actual source. So I expect to see 172.26, 1.10 here. But I think right now what R3 is, or the RP is trying to tell the FHR is I have no need for any of the other sources. If they do so here, put yourself in a register stop with them as well. But usually what I would expect to see here, let me see if this changes. Nope. So what I usually expect to see here is the actual source. So it looks like Junos is using some sort of optimization technique here, but the idea is the same. It's not a tunnel packet, it's a register stop. It should put R1 in a hold tunnel. So for the sake of keeping the length of the video manageable, what we will do is we'll bring this video to an end here. And in the part 2 of this, we'll start covering the next scenario. So the very first scenario is going to be the first receiver that comes online, followed by the source. So we'll actually go ahead and join the tree so that multicast packets can travel all the way from the source to the receiver. And that's going to be the next video. As for this video, I hope you've enjoyed it. Leave any comments and anything that you liked about the video or didn't like about the video. I'd love to hear from you. But other than that, stay tuned for part 2 of this video. Thank you.
Okay, so that was a really great video. Unfortunately, I kind of fell off the bandwagon here. We're just getting hellos, but we're not getting any of those other kinds of messages. So I'd love to troubleshoot it and figure out what's going on, and part of me wonders if I'm going to have to do that or just get confused during the test. Yeah, so, god damn it. You know what I'm going to do is just end the video for now, and I'm going to have to make a decision if I want to continue with this topic or just move on. I'm kind of tempted to just move on, so you know what, let's do that. Lunchtime and after work videos are going to be about Anycast, RP, MS, DP. This was specifically about PIM-SM. It looks like there is a part 2. Let's see if he's got anything for Anycast, RP, MSDP. Okay, so we've got PIM sparse mode, that's good. But I don't see anything for yeah, I don't see any of that. Huh. Oops. Whoops. Oh, here's SP technology. Oh, this is all on BGP. Yeah, like this video I should probably watch. God damn it. Oh, BFD I should probably watch as well. God damn it. Oh, am I gonna fail this test? I hope not. I don't want to. I don't want to fail the test. Okay, so here's part 2 of sparse mode. Here we go. So we've got some scenarios that are covered. Let's see if MSDP is covered. Okay, unfortunately I don't see MSDP covered. Yep, so there's a commenter here. Can you make some videos on MSDP? So I think it's pretty clear that he does not cover MSDP, otherwise that commenter that I'm assuming has watched every second of the video would not have requested that material. So that's going to be it for PIM-SM. I'm not even going to do scenario 2, which I might regret later, but right now my goal is to simply get through everything and then come back to something I don't feel comfortable in, or that I just glossed over and didn't do justice the first time. I am going to run out of time the day before the test. I'm going to feel like I didn't cover everything, and I'm not going to feel super prepared, I think, which is a bad sign, because I believe that for every CCNA, CCNP, JNCIE-SP exam that I passed, I've taken a lot of these exams before, when I felt the most confident is when I've passed. Going in feeling like, oh, I didn't cover this, I'm not comfortable with that, I believe that's when I've failed the exams. So it is important to have that confidence and say, no, I went over this a billion times, I know it's right. If I'm wrong on this, it's because there's an error in the test and not because I'm wrong. Having that level of confidence is a really, really good sign that you're going to pass. There are some situations where you'll just never feel confident with something, and you can still pass. But I've found that the more confident you are on test day, the more your confidence level is basically a measure for how well you prepared. So if you're not very confident, you're just not very prepared. Alright, but that's it for this PIM-SM. So I'll see you in the lunchtime video where we do AnyCast RP MSDP practice. So thanks for watching, see you in the next one.